Okay, so we have been looking at this notion of frames, which was introduced by Minsky. But around the same time when Minsky was talking about frames, there was this group at Yale which we was talking about this idea called scripts, uh, and we have already spoken a little bit about conceptual dependency that Roger Schank and his group had devised. Now we will look at how these conceptual dependency based representations are incorporated into structures which are called scripts, which are essentially as some natural language people would call as pragmatics. When they talk about syntax and semantics and pragmatics. So, it talks about the context in which you are listening to a sentence essentially. But before we do that, let me just quickly go over this kind of a structure. So, we have spoken about this semantic nets essentially. Okay. So, we have also talked about this notion of frames. So, the gray colored nodes that you can see in this slide, these are correspond to generic frames. So, for example, woman, company or camera, all these are generic frames, and the white colored nodes are individuals, and as you can see some of them are names of people. So, for example, Abhay and Akansha and Abiba and so on and so forth. The edges that you see are relations between these nodes, and we have talked about certain relations. So, we can see the instance of relation here. So, this says that Anhita is an instance of woman, and then there is a relation here which says that the camera company is a company. So, all these ideas that we got from frames and semantic nets are kind of, they all blend together, and here we have other kinds of relations. So, M stands for mother, for example, aunt stands for aunt, and lives in stands for example, Aiden lives in Bhopal, and so on and so forth essentially. So, this idea of semantic nets is basically to put everything together, so that related entities can be reached easily. So, relations can be uncovered more easily essentially. So, whenever we talk of such structured representations, we essentially talk about two kinds of hierarchies. One is the abstraction hierarchy, which we are quite familiar with. So, for example, we use the term taxonomies. So, for example, we mentioned that royal elephants are elephants and elephants are mammals and that kind of stuff. So, relations between individuals and classes, which is the instance of relation that we talked about, which is shown here in this dotted line. So, here this long line that you see here, this kind of separates the concrete from the abstract, or the individuals from the generic concepts. So, on the right hand side are the concrete or individuals, and in the bottom you can see, let us say in some domain there are some elements, and these elements here for example, belong to a certain class here, and so they are instances of something. So, let us say if these are students, all these instances are all the students are instances of, let us say, a computer science student or something like that. So, you can have a computer science student, you can have a mechanical engineering student, and so on, all those are instances or are types of other students and so on. So, these dotted lines show the abstraction hierarchy, which is captured by the is and the instance of relationship in frames. These solid lines that you see here, this we can call as an aggregation hierarchy, which says that when things come together to form new entities. So, for example, you might say that an engine and a steering wheel and a seat and a chassis and a body together form a car, for example. You could try to define a car like that. So, then many things come together to form a new entity, something that we have talked about earlier. The process of reification can be captured in aggregation hierarchies essentially. So, here is an example of a knowledge base, for example. Again, the gray nodes are the generic nodes. So, this is about bridge and bridge players. So, bridge, of course, those of you who are educated will know, is a game which is common commonly played in many places. And this particular knowledge base is talking about a particular team which existed about 50 years ago. It was called the Italian blue team, which had these 6 players: Belladonna, Everly, Garozzo, Forte, and so on. And essentially we have this instance of link says that they are human bridge players who are sports persons, who are humans, and so on and so forth. And at the same time we have this aggregation hierarchy, which says that, for example, these 2 players formed one pair and these 2 players form another pair, and these 3 pairs together form a team, and a team is an instance of a team, and that kind of stuff essentially. So, this kind of knowledge representation is becoming more and more common nowadays essentially. There was this idea which came from the Yale group, which they call as memory organization packets. It is basically again they are talking about the same abstraction and packaging hierarchies. So, supposing you are talking, for example, of visits essentially. So, you want to remember we just talked about planning a trip and things like that. So, you could talk of a visit frame essentially. Then you could say that there are 2 kinds of visit frames. You could either be visiting a friend or you could be visiting a professional. Then visit professional could be further divided into 2 kinds of frames. Let us say you are visiting a lawyer or you are visiting a dentist. So, this is a abstraction hierarchy essentially. At the same time there could be a what they call as packaging hierarchy, which is also I am calling the aggregation hierarchy. There could be the fact that a visit to a professional could be broken down into 4 parts, which for example could be that you make an appointment, then you go and wait in a waiting room, then you consult with the professional, and then you pay the professional essentially. So, these are sort of sub parts of the professional visit professional activity essentially. In particular, the consult part could itself be could be of 2 types. For example, if you are visiting a lawyer, you may be wanting to sign a contract or something, or if you are visiting a dentist, then you may want your tooth to be extracted or something like that essentially. And then of course, the lawyer visit could itself be seen as an aggregation of these 4 concepts, and these 4 things would be make an appointment, wait in the waiting room, sign your contract and pay, and then that is the end of it essentially. So, this kind of representation where you can see the same hierarchical structures, but there are 2 kinds of hierarchies we are talking about. One is the abstraction hierarchy, which is talking about something like taxonomy, and the other is an aggregation or packaging hierarchy, which puts together things into larger wholes essentially. So, this idea of a script is that in stereotypical situations you do a sequence of activity which is typical to that situation essentially. And what Shank and his group showed when they talked about script and this program that we are going to look at called SAM, which is a script applier mechanism, was to show that how stories could be understood if you had this kind of knowledge stored in your system essentially. So, a script is basically a collection of episodes, and SAM, which is this program that we are talking about, which was written by Shank's PhD student as part of his PhD. It reads stories in a top down predictive manner. So, we have already been, even when we were talking about conceptual dependency, we said that this predictive understanding says that you already have certain notions in your head or a system or whatever you want to say, which are used to make sense of the incoming information essentially, and the kind of notions that we are talking about are scripts essentially. So, SAM was a program which was used to demonstrate reading of newspaper stories in what situations are kind of larger than scripts, describing motor vehicle accidents, plane crashes, train wrecks, oil spills and state visits. We will see a couple of examples as we go along this thing. Situations are bigger than script in the sense that they contain larger amount of activity, and later on the idea of organizing situations into MOPs, which is what we just saw, memory organization packets, that came up a little bit later essentially. Now, a script itself is a pattern of connected conceptualizations. These conceptualizations are represented in conceptual dependency language that we have already talked about, and it has this notion of roles and props essentially. So, roles are the people who are doing something in the script, and props are the other things which are inanimate, which are part of the script essentially. So, in that sense the word script is very similar to what you would use in theater or in cinema, where you say this is a script, these are the, so here is a hero and there is a heroine and there is a villain and there is a knife and there is a jeep, and then all this kind of stuff are parts of the script essentially. So, you describe things in terms of that essentially. So, which is why whenever you go to watch a Bollywood film, you already have some idea of what you are going to see, right. So, each script provides a pre-stored set of expectation of what will be read. In this case, they are talking about natural language understanding. So, they are reading stories essentially. So, here is a example of a subway script, or you might say a metro script, or if you are in Chennai, then MRTS script or something like that, that you talk about. So, episodes are described here in two ways. One is on the top, which is in English, which says that the patron enters the station, and just below that is this main conceptualization, which uses terms from conceptual dependency. So, it says that the patron group P transits to inside part of the station. So, that is the first event that you know happens if you are taking a train to some place, train or a subway or a local train or whatever you want to call it. Oops. Okay. So, let us see, let me get it started. Okay, now it will go by itself. So, the first thing that happens is that the patron enters the station and then either directly goes to the gate or goes to some counter and buys the ticket, depending on what is the situation. Then you go to the platform and then you wait, and then a train comes by or a subway arrives on the platform. Then if that is a train that you want to catch, then you get into the train, otherwise you wait and another subway arrives. At some point you get into the train, enters the subway and sits down, hopefully you find a seat, and then the train goes to the next station. If that is the station you wanted to get off, you get off, otherwise you wait, and then the train goes to yet another station, and then eventually the patron gets off the train essentially. Now, this is a typical script which tells you what to expect when you talk about somebody taking a subway or a metro or a local train or something like that. And this kind of a script can be used to understand stories essentially. So, the whole point of this exercise is that whenever somebody is telling a story, they do not spell out everything in total detail essentially. They might say a few things. So, for example, you might say Suresh went to the canteen, he had a dosa. If I just tell you this much, you form a much larger picture in your head. For example, that if it is the IIT canteen, then he must have stood in a line, then he must have paid at the counter and asked for a coupon, then he could have taken the coupon and gone to the serving counter and waited for a dosa to come, and that kind of stuff essentially. I have never told you that, but you expect that to happen, and why do you expect that to happen is because you already know what happens typically in a restaurant or things like that. So, that is the whole idea of scripts essentially, and what Shank and his group showed that it could be used quite effectively to demonstrate story understanding. So, let us say you read the first sentence, which is denoted abstractly here by this blob, which you can see I hope, and then you have to instantiate a script, that somehow from your collection of scripts you have to decide that this is a script that is applicable. The moment you do that, you generate a set of expectations, that if this is a script, then this is what you might hear about essentially. And then when the second sentence comes in, you want to verify whether it matches the thing. So, you try to match it with some element in the script. So, once it does, then you know that the script that you were talking about has been activated, and then the third sentence comes and so on and so forth. So, understanding here or predictive understanding here is essentially being able to retrieve the right script from your memory and matching the episodes or the actions with episodes in the script essentially. So, what are the kind of inferences that scripts would make? So, you could do what they call as causal chain completion. So, for example, if I said that Suresh went to the canteen and had a dosa, there must have been other things which happened in between, which you infer because that is what typically happens in that kind of a situation. So, it maintains both causal and situational continuity. Then you need to do what they call as role instantiation. You have to find out which person is playing what role in the script. So, again in the restaurant script, for example, there is a customer, there is a cashier, there is a person who serves you, and that kind of stuff. So, all these are roles in the script, and you have to find out who is playing what role. Sometimes you need to figure out that these two persons are the same person essentially. So, for example, once they may be mentioned by a name and another time they must be mentioned by something else. So, you should be able to identify that we are talking about the same person. So, this is basically typically like being able to resolve pronouns and things like that. So, if you have this example, for example, John walked into the subway station and he went to the express platform, then you can infer that he must have bought a ticket. If that is a typical situation, then you can infer that John is a rider in the script, and then there must be a ticket window and gates and platforms and all that kind of stuff. And that in the second sentence, which is that he went to the express platform, we are still talking about John. So, that is a part of role merging essentially. So, some implicit inferences that you need to make. So, for example, John went to the movie theater, he went to the ticket counter and asked for a ticket. Then one of those sentences will match the expectation that the patron goes to the cashier essentially. Of course, we have not said, the story does not say that he goes to the cashier, the story says that he went to the ticket counter essentially. So, somewhere you need to make a situational inference that the cashier is the one who sits at the ticket counter. So, if he is gone to the cashier, then he has gone to the ticket counter essentially. So, this kind of inferences may sound very trivial to us, but if you want to create an explicit representation of the story, then you have to make them essentially, and your knowledge base must allow you to make such kind of inferences. And then you can expect that the patron is expected to buy a ticket at that point, and that you have to pay for the ticket, and all these are expectations that would not surprise you essentially. So, let us look at some examples which were treated by Sam, this program which Cullingford wrote. And there is a small program which says John went to a restaurant, he ordered a hot dog, the waiter said that they did not have any, he asked for a hamburger, and when the hamburger came, it was burnt, and he left the restaurant essentially. So, it is not such a straightforward story. It has sentences which a simple language processing program would be find it difficult to handle. For example, what happened when it was burnt, what does it mean, and what do you mean by saying when the hamburger came essentially? I mean, is the hamburger a living creature which can came? So, you can of course understand that if you know what happens in the restaurant, that hamburgers do not come walking or something to you, that somebody serves them to you essentially. So, you must be able to match the sentence when the hamburger came with the fact that the waiter served it to him essentially. Now, this program SAM works only with CD representations. Remember, CD is the conceptual dependency structures that we talked about. The semantic parsing which happens earlier is done by this program called LE, which we have looked at very briefly earlier. And then there is a text generation program which is called Babel, which generates the answers that we will see it generates essentially. Babel you might associate with something called Babel fish, I think, which was there in this novel called Hitchhiker's Guide to the Galaxy, which if you have not read, you should go and read. So, here is an example of what this program SAM could do. This example of course has SAM running in the background, and this example was generated by another research student called Wendy Lehnert, whose PhD thesis was on question answering essentially. So, question answering is not such a straightforward thing, because you have to first understand the question and only then you can generate the answer. So, this is the same story that we just saw. We will look at some examples of how SAM performed on this story essentially. So, these are real runs on the program, and this program was written much before most of you were born essentially. So, it is not a recent program essentially. So, let us say we have this question, did John sit down in the restaurant essentially. So, somehow this program has managed to answer probably. So, remember we had talked about this program called Margie, which did some common sense inference about the world essentially. So, this Margie is also sitting somewhere in the background essentially. So, they are making some inferences which are plausible. So, these are not logical inferences essentially, and they are just generated the answer probably essentially, because the story does not say anywhere. The story simply says he went to the restaurant, he ordered something, it did not come, and so on and so forth essentially. Now, this is a easy question. Did John order a hot dog? So, the system can answer yes. Then we can ask, did John eat a hot dog? And then this is answer generated by Sam and Wendy Leonard's program and so on and so forth. Then there are some more questions, as you can see. What did the waiter serve John? The waiter served John a hamburger, even though the story says that when the hamburger came. Why didn't John eat the hamburger? Or you could ask whether John ate the hamburger, but because the hamburger was overdone, so it is interpreted burnt as overdone. Did John pay the check or bill, as we say here? No, John was angry because the hamburger was overdone. Nowhere it says he was angry, but this is something which is kind of a plausible inference that you could make essentially. Here is another situation. Remember, a situation is larger than a script essentially, and it is a container for scripts which will have other things like car accident and ambulance ride and hospital treatment and police investigation and so on. So, here is another example. Friday evening, a car swerved off route 69. The vehicle struck a tree. The passenger, a New Jersey man, was killed. David Hall, 27, was pronounced dead. Now, remember, see these two separate sentences are talking about the same person. First, you say the passenger, a New Jersey man, was killed, and then you say David Hall, 27, was pronounced dead, and most of us would associate the passenger with David Hall essentially, as seen by the medical examiner. Then Frank Miller, 32, the driver was taken to some hospital and he was treated and released, and no charges were made. And patrolman, which is another name for policeman, Robert Onofre, investigated the accident essentially. Now, once you have a representation, you can always use a generation to generate a summary. In a later example, we will see that this generation can be done in different languages. In this particular case, the generation is in English. So, the input story is given on the top and the summary is given in the bottom, which says that an automobile hit a tree near the highway. It never says, okay, the vehicle struck a tree is what is said here. 4 days ago, all that has been inferred. David Hall, age 27, resident of New Jersey, the passenger died essentially. Okay. So, all that is put together in the summary, and the driver Frank Miller was slightly injured, and the police department did not file any charges. So, as I said in a later example, I will show you a Spanish summary as well. So, again let us look at question answering. If you ask these questions, was anyone killed? The system can answer yes, David Hall died. Was anyone hurt? This Frank Miller was slightly injured. Yeah, so I am just guessing here. Okay, so this is a kind of plausible inferences because the story says that the driver was taken to the hospital and he was treated and released essentially. Well, this is just guesswork, I think, but you in the hospital script or situation, it would say that if you are admitted, for example, then you are seriously injured. If you are not admitted, then you are slightly injured. So, some simple rule like that, do not read too much into that essentially. So, you have to make all these inferences. Vehicle is a car, New Jersey man is David Hall, and that he was injured in the car crash and this kind of thing, because you are talking about a script essentially. Now, scripts are only in some sense the beginning of understanding, because they only talk about stereotypical events, what happens in a typical situation, and if the story conforms to the stereotypical event, then you have understood the story. But real world stories, of course, do not always conform to stereotypical situations, and one must talk about other kinds of ways of understanding stories, and maybe after a couple of classes we will look at how people reason with goals and plans essentially, as to why did somebody do that. When we talk about scripts, we do not ask the question why, we only ask the question what happens after next. So, it is like a child when it is understanding a story who says that okay, so what happened next, then what happened next. So, it is a typical story essentially. You went to a restaurant, you sat down, then what happened, you ordered your food and so on, that kind of stuff. You can't answer questions about why did somebody do something. So, for example, if you had this story at the bottom here which says that Spillane strolled into the cafe Budapest, and while the waiter was taking his order, the owner, the notorious mafia figure, approached them threateningly. Now, obviously, this is not part of any script essentially. I mean, if you had scripts for these kind of things, then you would have to have hundreds and thousands of scripts essentially. So, we will look at goals and plans and things a little bit later essentially. Let us look at the structure of SAM, and then in the next class we will look at a more detailed example essentially. So, the story text is input to a program called LE, which we have already spoken about, English language interpreter, and then it goes to a program called PP memory, which is a picture producer. Remember the term from conceptual dependency memory, and it has some kind of common sense knowledge. It has got some kind of taxonomy and some things which are generally true about the real world, and then it is passed on to the applier, which tries to obtain the relevant script and applies it and produces a story representation. Now, of all this activity, only the one which is showed in the which is not shown in the shaded part, which is that of LE, is language dependent essentially. Everything else which is shown in the shaded area is language independent. So, this is of course a nice thing to do, because it means that your reasoning program, even though see their main concern was natural language understanding, they were not working in logic or reasoning just as we are, or knowledge representation. Their concern was natural language processing, and what they showed and what some other people also showed, including people like Charniak, was that most of the work in natural language processing is to do with knowledge representation and not so much with language processing itself essentially. So, if you want to make sense of stories, then you should create representations and then reason with those representations, and those representations, as we have seen, are in conceptual dependency, even though they use terms like move for example and ingest, but we do not use the meaning of move and ingest essentially. They are just terms for us, and they tell us, for example, if you are ingesting something, then the actor must be animate and the object must be edible. All these kind of relationships exist, which means of course that you can write these programs in any language essentially. So, if you have this PP memory and applier and everything and script data, then you could develop a parser for let us say Hindi or Tamil or Marathi, and you would still work essentially. So, these are the different phases that happen. So, initially LE extracts the conceptual elements that are explicit, it does not do any inference. We will look at examples. So, I just want to give an overview right now. Then the picture memory assigns tokens to PPs. Remember, PPs are picture producers and acts are the actions in the output of LE. So, you need to create representations, right. So, token is the word that they use, which is basically like a variable. Also generates tokens for roles in the script, and then there are some things like permanent tokens, like for example Manhattan, which current day researchers call named entity. So, you will find a whole lot of papers in text processing and natural language processing, which says what are the strategies you can use for named entity recognition. So, if I am saying the Prime Minister of India, how do I recognize that this is referring to a person which is well known, or if I am talking about a city like Delhi or Manhattan, what is it that you are talking about. So, these are called named entities, and they are very important in text processing essentially. So, this PP memory basically tries to match the scriptal roles with the incoming actors in the conceptual dependency structure. So, when you say John took a BMT to Manhattan, then these are permanent tokens that the program needs to, the PP memory needs to find to sort of be able to. So far we are not yet spoken about a script. So, eventually we will essentially, and then if he says that at the theater he walked over to the counter and the usher took it from him, then the role merging component should be able to recognize that this it refers to the ticket and he refers to John and things like that. So, the PP memory is basically a semantic memory which has got ontological knowledge, and we will talk about the word ontology as we go in the next few weeks. Whereas, in contrast scripts have episodic knowledge, they tell you what happens in a typical situation and give you that kind of a knowledge essentially. The script applier has three kind of problems to solve. One is to locate the input in the database of scripts, which means you must be able to retrieve the relevant script essentially. So, if you retrieve a wrong script, then you will have a totally complete understanding, complete misunderstanding of the story essentially. So, if you have to do something meaningful, then you must be able to retrieve the script, and as you can imagine that the more the number of scripts in your knowledge base, the harder the problem will become essentially. So, we will see how they used to how Sam identified what are the scripts that have to be used essentially. Then the script applier has to set up and make predictions about the inputs that would follow. So, as you are listening to the story, you should generate expectations about what else you would listen to essentially, and that will come from the script essentially. So, it is a job of the applier essentially. And then finally, instantiating the appropriate segment of the script up to the point referred to by the input. It builds an explicit and detailed representation of the story, including the inferred events essentially. That is a job of the script applier. Active scripts are defined by context. So, the kind of context are a list of patterns which predicts which inputs will be seen at a given point of a story. A binding list which links the tokens produced by the PP memory with the script variables. So, remember these are two separate things. The PP memory is the input in some sense represented in some form, and the script is talking about what is happening. Then a record of which scripts are which scenes are currently active. A list of scriptal inferences which have happened, which may interfere with the normal flow of the script. So, for example, we saw this example of Spillane going into a Budapest cafe and the owner walking threateningly towards him. Now, that is something which interferes with the normal flow of the script, and the program should be able to recognize that something is going wrong here, and it should be able to maintain a global strength indicator which says how much it believes the story conforms to the script essentially. So, I will stop here. In the next class, we will look at more detailed example of scripts, which will also give us some idea of how everything is happening in SAM essentially. Okay.